So this week in AI was wild. The floodgates just opened. We got an AI that can restore any ruined photo, blurry, noisy, even underwater, to crystal clear perfection. A true Photoshop killer that lets you add or remove anything, mask-free. A model that can finally create complex scenes with multiple characters actually interacting. An AI that turns your spoken words directly into speech or sound effects.
Talking here. Hello.
A tool that transforms any report into a live web page and a full podcast instantly. And yes, the Holy Grail, a generator that can create videos of literally infinite length. I'm about to show you how it all works. Let's get into it. First up, we have FLUX-IR, a seriously impressive new AI for all-in-one image restoration. It's based on a research paper called Learning Efficient and Effective Trajectories for Differential Equation-Based Image Restoration, and its goal is to take any kind of degraded image, whether it's blurry, noisy, underwater, or in low light, and restore it to a crystal clear version. It handles a whole suite of tasks, including super resolution, de-blurring, denoising, and even removing rain or snow from a scene. Let's jump into some examples because they are stunning. Take a look at this underwater scene. The original is hazy and washed out, but after FLUX-IR gets his hands on it, the contrast is perfect and the fish are sharp and clear. Then there's this penguin where the original shot is incredibly noisy and grainy, almost like a heavily zoomed-in photo. The restored version is just superb. You can make out the texture of the feathers with amazing clarity. It's fantastic at both super resolution and denoising. Similarly with this parrot image, all the graininess from the original is completely gone, leaving a much improved, clean image. What's really cool is its ability to preserve the original content. Look at this example with the falling snow. FLUX-IR removes all the messy flakes, but if you look closely, the people in the background are completely unaltered. It surgically removes the degradation without changing the subjects, which is a huge deal. It can handle blurry photos like this motorcycle and even extreme low light conditions. Here's an image that's almost completely dark. You can barely see anything, but the model transforms it into a full daylight scene, revealing all the objects that were hidden in the shadows. It also works on things like raindrops on a window, making them completely vanish. And this isn't just about looking good. The numbers prove its performance. The research paper is packed with comparisons against other top-tier models, and FLUX-IR consistently comes out ahead. For some image deraining tasks, it achieves a PSNR score improvement of up to 2.1 dB over previous state-of-the-art methods, which is a massive leap forward in restoration quality. So, what's the secret sauce here? Under the hood, FLUX-IR is built on a massive 12 billion parameter diffusion model called Flux. The problem with typical diffusion models is that they can be slow. The researchers behind FLUX-IR developed a two-part solution. First, they use reinforcement learning to find the most efficient path from the noisy image back to the clean one, kind of like a GPS finding the fastest route. Then, to make it even quicker, they use a technique called cost-aware trajectory distillation. This takes that complex optimal path and boils it down into just a few steps or even a single one, delivering that top-tier quality in a fraction of the time. For those of you who want to get your hands on this, you're in luck. The code has recently been made available on GitHub. This page provides all the details for getting it set up. The paper doesn't list specific VRAM requirements, but given it's a 12B parameter model, you'll probably need a powerful machine to run it locally. As always, I'll have the links in the description below for you to check out. All right, next up we have a fantastic new tool from Adobe Research called OmniPaint. It's a master at realistically adding and removing objects from any photo. It treats these two jobs not as separate tasks, but as two sides of the same coin. And the results are pretty incredible. Let's dive into the example, starting with object removal. First, check out the scene of a tiger coming to a stream for a drink. You hover over it, and just like that, the tiger is completely gone, and the background is filled in so perfectly, it's like it was never there. Here's a dog jumping into the water. One click, and it completely disappears. What's really impressive is how it handles an object's effects on the environment. Look at this other dog and its shadow on the ground. When OmniPaint removes the dog, the shadow goes with it. The same thing happens with these two elephants walking on a path. They and their shadows are erased seamlessly. Here's a boat on the water, move the mouse over, and it's gone without a trace. Or this person carrying a bag with their shadow cast on the wall behind them. Both the person and the shadow vanish. The background reconstruction is top-notch. Look at this motorcycle parked in front of other bikes. When it's removed, the parts of the bikes that were hidden behind it are rendered in perfectly by the AI. The really mind-blowing examples involve reflections. Here's a person jumping through glass and you can clearly see the reflection. The tool is smart enough to remove both the person and the reflection, even if you only select the person. In another one, there's a frog in the water with a butterfly on it. If we select the tiny butterfly, it gets erased perfectly, and so does the subtle reflection it was casting on the water surface. So that was removal. Let's look at object insertion. Here's an image where we want to add a Coke bottle. You just select the area, provide the reference picture of the bottle, and boom, it's inserted flawlessly. It even generates a realistic shadow that matches the lighting and direction of the other objects in the scene. It's also incredibly context-aware. In this shot, a hand is holding a coffee cup, and the area is a bit blurry. We want to insert this toy into that spot. The AI understands the blur, so it inserts the toy as a blurred object, making it look like it's actually part of the photo, not just a sticker. You can also use it for more complex edits, like changing clothes. Here's a person, and we want to put this shirt on them. You select the area of their torso, provide the reference image, and now they're wearing that exact shirt right down to the identical text and logo. Want to try a different look? Here's a white shirt and black tie. In the aftershot, it's the same person, now wearing the new outfit perfectly. The insertion is just incredibly well done. It works for accessories too. If we select the area around this woman's eyes, we can give her sunglasses. Here's the first pair, which looks amazing on her face, and here's the second pair, added just as impressively. This is a seriously useful tool. So how does it pull all this off? OmniPaint is built on top of the powerful Flux diffusion model, but it's trained with a clever strategy the researchers call cycle flow. Instead of just learning to remove things or add things separately, it learns them as a cycle. The AI is trained to take an image, remove an object, and then immediately use the insertion part of its brain to put that same object right back where it was. By forcing itself to get back to the original image, it develops a deep understanding of how an object should realistically interact with its environment, how it should be lit, where its shadows and reflection should fall, and how it should blend in. This technique allows it to learn from a massive amount of unpaired images, making it far more robust. And the results from the paper show it consistently outperforms other models like PowerPaint and Clip Away for object removal and beats competitors like AnyDoor and Imprint for object insertion, especially in keeping the inserted object looking true to the original. For everyone wanting to try this, the code has recently been made available on their GitHub repository. You can find the complete procedure for installation and how to run this locally. There are no specific details on the VRAM requirements, but looking at the quality, I'd expect you'll need a decent GPU to run it locally. I'll put the link for this tool in the description as well, so you can check it out for yourself. Okay, the next tool we're looking at is Blip 3.0 Next. This is a powerful open-source foundation model that's designed to significantly improve the quality and prompt-following ability of image generation. It has a fantastic understanding of prompts, meaning its visual comprehension is top tier, which allows it to follow your instructions with incredible accuracy. Let's jump into the examples because they really show off the power of the reinforcement learning used to train this model. The prompt for this first one is an astronaut helmet, a red apple, and a wooden horse. The image generated by the base model is okay, but you'll notice the red apple is completely missing. It only managed to generate the helmet and the horse. But after applying the Blip 3.0 Next fine-tuning, you can see all three objects are perfectly rendered: the astronaut helmet, the wooden horse, and the red apple. It's the same story with this next prompt: a teapot, a skateboard, and a goldfish in air. Without the model's special training, the result is a bit of a mess. It looks like it put fish swimming inside the teapot, and the skateboard only has 2 wheels. But in the version generated with this new method, you get a much cleaner, perfectly rendered teapot with no fish inside, a goldfish floating separately in the air, and a proper 4-wheeled skateboard underneath. The improvement in how it handles distinct objects is just massive. This enhancement is especially noticeable when it comes to rendering text, which is a classic weak spot for many AI image generators. The prompt for this one is a road sign warning, next gas 100 miles. The base model tries, but the text is garbled, showing just next and 100 without the other words. But after being trained with Blip 3.0 Next, it generates a perfect road sign that clearly reads next gas 100 miles. Likewise, in another example, the text on a supermarket sign comes out as gibberish that looks something like Pizza Nords, C in the base version, but the fine-tuned model nails it, displaying the words frozen goods section perfectly. There are many more examples showing just how impressive this text rendering ability is.
To back this up with data, the team put Blip 3.0 Next head-to-head with several other major models. Even though it's a relatively compact 3 billion parameter model, It achieved the highest overall score in the GenEval benchmark, outperforming larger models like Qwen Image and Bagel in prompt and instruction following. So, how does this actually work? Blip 3.0 Next uses a clever two-stage hybrid architecture. When you give it a prompt, it first goes to an autoregressive model, which is brilliant at understanding language, context, and the overall structure of an image. This model creates a detailed blueprint of the image in the form of discrete tokens. Then, that highly structured blueprint is passed to a diffusion model, which is an expert at rendering photorealistic, fine-grained details. The diffusion model uses that blueprint as a strict guide to generate the final high-quality image. The real magic comes from applying reinforcement learning directly to that first autoregressive model. By rewarding it for accurately following complex prompts, they drastically improve its comprehension, which is what leads to those huge quality jumps we see in the examples. For anyone who wants to dive in and try it, the project is completely open source. If you go to their GitHub page, you'll see they've released all the code and full instructions on how to use it. The pre-trained data and instruction tuning data are already available, and they plan to release the image editing data soon. The 3 billion parameter model weights and all the training code are out there for you to use. I will add the link to it in the description below. Now, let's move on to the next model, which is a really cool take on audio generation. It's called STAR, which stands for Speech to Audio Generation via Representation Learning. This is a true speech-to-audio model, meaning you don't type your prompt, you speak it. You give it an audio command, and it generates whatever sound effect, voice, or music you just described. This is the first end-to-end framework of its kind, and it's designed to be much faster and more accurate than older methods. Let me show you some examples because the quality is fantastic. The first spoken prompt is for a cat meowing and a young female speaking.
A cat meowing and young female speaking.
Here's the 10-second clip the STAR model generated.
Talking here. Hello.
As you can hear, it's a perfect blend of a cat meowing and a person speaking, both crystal clear. For comparison, here's the same prompt run through a traditional cascaded system. That version is full of noise and the quality just isn't realistic, unlike STAR's output. Next, a simpler prompt. Sustained industrial engine noise. Here's STAR's result. That's a very convincing 10-second clip of an engine humming. Now listen to what the other model produced for the same prompt. As you can tell, that sounds more like random static than any kind of industrial engine. The model is also great with more complex, nuanced prompts. Here, the prompt was a woman talk and a baby whispers. This is STAR's generation. It's a fantastic 10-second clip where you can clearly distinguish the woman's voice from the baby sounds. Now let's check the generation from the other model. In that version, the woman isn't talking normally. It sounds like she's also making baby-like sounds, failing to separate the two concepts. STAR's generation is just perfect. But my favorite example is this one, for the prompt, a man speaks, followed by a toilet flush. Listen to STAR's output. You clearly hear a man talking, then a distinct sound of a toilet flush, and then the man's voice continues. It perfectly understood the sequence of events, which is very impressive. So what makes it work so well? The secret is in its end-to-end design. Older systems are typically cascaded, meaning they first use an automatic speech recognition model to turn your speech into text, and then a separate text-to-audio model to generate the sound. This two-step process is slow, and any errors made in the first step get passed on and amplified in the second. The paper shows that this cascaded approach has a delay of at least 156 milliseconds. STAR cuts out the middleman entirely. It uses a sophisticated speech encoder and a bridge network to pull the semantic meaning directly from the raw speech waveform. A flow matching model then generates the audio from this direct understanding. This makes it incredibly efficient, slashing the processing latency by nearly 77% down to just 36 milliseconds. Not only is it faster, but human evaluators also rated its audio quality and relevance to the prompt significantly higher than the cascaded systems. If you want to try it out, the code was recently released on their GitHub repository with full instructions on how to install and run it. The paper doesn't mention specific GPU RAM requirements, so I can't provide that info. Even better, they've launched a Hugging Face space for it. You can go there right now and test it yourself. I tried it with a spoken prompt for birds chirping and a horse neighing.
Birds chirping and a horse neighing.
It took about 10 seconds to generate, and the result was amazing. You can perfectly hear both the birds and the horse exactly as requested. As always, I will provide the links to everything in the description. Now, let's move on to our next tool. This one is really interesting. It's called OmniInsert, and it comes from the research lab at ByteDance. The paper describes it as mask-free video insertion of any reference via diffusion transformer models. In simple terms, this model lets you take any object or person from a reference image and insert it into any video. No complex masking required, and it integrates them in a seriously impressive way. As you can see in these examples, it handles a huge variety of styles. Here's a simple video of a guy talking in selfie mode. If you want to insert this teddy bear toy, the after video shows the toy sitting right on his shoulder, even moving and interacting a bit with the scene. Crucially, the guy's face and the original video are completely unchanged. The model just seamlessly adds the object. It also works on animations. Look at this cartoon-style video where a new character is inserted. In the final video, you can see the character we added and the original character are actually kissing. This shows how wonderfully it can handle interactions. Notice the lighting on the new character's hair, reflecting the sun in the background. That's a very impressive detail. Here's an anime generation where a second character is added to the scene. In the resulting video, the new anime character has been perfectly integrated, and they're both talking and interacting with each other. But it's not just for cartoons, though. Here's a realistic example of a chef in a kitchen. The model inserts a new female character into the video, and you can see her seamlessly interacting and talking with the chef as if she was there all along. In another photorealistic video, a man is opening the door to an empty room. But when we give the model a reference image of the Joker, the final video shows the Joker appearing from behind the door as it opens. It also works great for product placements. Look at this man speaking at an event. If we want to put this specific cap on him, the resulting video shows him wearing it. Or if we want him to wear these headphones, you can see how seamlessly they've been added. Even small details are handled well. Here's a close-up of a hand opening a drawer. When we tell it to insert this mouse, the drawer opens to reveal the mouse sitting inside. Here's another example of a man talking in front of a microphone, and in the after video, he's wearing the exact cap we provided. The insertions can also be very dynamic. For instance, this man is opening the trunk of his car. If we tell it to add a character, the final video shows this character emerging from the trunk as the door opens. This is a very powerful model. The comparisons really highlight how good it is. The researchers provided a side-by-side with other models using a famous movie scene of a man on the phone. The prompt is, add a woman cuddling up to the man. A competing model, Qwen, adds the woman, but she's just standing there calmly. In the result from OmniInsert, she is actively interacting and cuddling, perfectly matching the prompt. Pika Pro's generation, on the other hand, is quite poor. The woman looks completely different and the scene is a mess. Here's another comparison with a sunflower video. When we ask it to add a girl, OmniInsert's generation shows her standing among the flowers in a very natural way, while in the other model's videos, she just looks pasted in abruptly. Overall, the quality here is just on another level. So how does it achieve this? The biggest hurdle for a task like this is the lack of training data. You need millions of before and after video pairs which just don't exist. So the researchers at ByteDance built an automated data pipeline called InsertPipe. It uses a whole suite of other AI models to automatically create its own training data by taking real-world videos, identifying subjects, digitally erasing them to create a before video, and then pairing it with the original after video. To make the model's insertions more natural, they developed a technique called insertive preference optimization, where they fine-tune the model using a curated set of videos that reflect human preferences. On top of that, it uses a smart module called a context-aware rephraser. This takes your simple prompt, analyzes the video and the reference image, and automatically rewrites your prompt with much more detail to get a better result. This level of sophistication is backed by user studies where OmniInsert was preferred over 68% of the time for comprehensive quality against top commercial competitors like Pika Pro and Qwen. For those wanting to try it, if we go to their GitHub page, you can see that the code has not been released just yet. They've only published the paper so far. However, releasing the inference code and their new insert benchmark are on their official to-do list, so it should be coming soon. I'll keep an eye out and we'll update you when they do. For now, I've put the link to the project page in the description for you to check out all the amazing examples. Next up, we have a model called Stable Video Infinity, and its purpose is right there in the name. Infinite-length video generation with error recycling. This is a fantastic new approach for generating incredibly long, coherent videos, and the team behind it has just released all the details.
Now, a quick heads up on the examples you're about to see. The original files are massive in both length and size, so they've been compressed for the website. The quality might not look perfectly crisp, but when you compare it to other long video models, the results are in a league of their own. Let's start with this 44-second Iron Man scene generated from a very detailed prompt. When you look at the comparison with FramePack and streaming text to video, two other models that claim to support long-form generation, the difference is night and day. Their generations remain more or less static. The scene barely changes. In contrast, Stable Video Infinity delivers proper dynamic scene changes while keeping the video quality high. It's a similar story with this Goku example, which was generated from another very long and detailed prompt. The two models on the left are basically stuck in one place, with Goku remaining static and the scene transitions looking rough, but the generation from Stable Video Infinity is much, much better. It's not flawless, you'll still spot some issues, but for a video that runs for 1 minute and 14 seconds, it's a huge step forward. The model also excels at creative video generation. Here's a 30-second clip of a small puppy generated from a narrative prompt. You can see it sitting in a garden, getting up and shaking its head. A moment later, a butterfly appears, and then a squirrel shows up. The model follows this multi-step prompt incredibly well, and the whole 32-second video feels coherent. In another example with a dog, you can see the other models on the left struggle, but the video on the far right from Stable Video Infinity is much more interactive. The dog plays with a person's hand and then interacts with another person. Again, it's not perfect, but it's a decent and far more dynamic generation than the others. You'll find tons of other examples, including what they call ultra-long generations that are almost 3 minutes long. In these, you can even see text rendered on the screen. The videos on the far right are all from this model, and the results are quite good, with multiple different scenes changing smoothly. There are flaws, for sure, but compared to previous methods, this model's ability to maintain a story over several minutes is unparalleled. Finally, the model also supports multimodal conditional generation, like audio-guided talking animation. This is where you give it an audio clip and a photo, and it generates a talking video. The results are much better than its counterparts. For instance, all three models here were given the same image of Barack Obama and the same audio. For the first 10 seconds, 1, 2.1, and Multitalk look decent, but after that, their faces start to distort, and the generations become a messy, uncanny mess. With Stable Video Infinity, however, Obama's appearance remains consistent and realistic for the entire 1 minute and 10-second clip. His face doesn't get distorted, and the lip sync, while not flawless, looks very natural.
Rewards of living in America without taking on the responsibilities of living in America. And undocumented immigrants who desperately want to embrace those responsibilities see little option but to remain in the shadows or risk their families being torn apart. It's been this way for decades. And for decades, we haven't done much about it. When I took office, I committed to fixing our tradition of welcoming immigrants from around the world has given us a tremendous advantage over other nations. It's kept us youthful, dynamic, and entrepreneurial. It has shaped our character as a people with limitless possibilities. People not trapped by our past, but able to remake ourselves as we choose. But today, our immigration...
You can also use it for skeleton-guided dancing animations. Here, it takes a reference skeleton video and a single image. While neither this model nor its competitor UniAnimate are perfect, if you compare them side by side, Stable Video Infinity's result is noticeably better and more fluid. To really push the limits, the creators even generated an entire 8-minute Tom and Jerry episode in one continuous shot. As you can see, Tom and Jerry are up to their usual antics. While the quality does start to degrade after a few minutes, there is simply no other model out there that can generate a continuous, coherent video of this length. The model doesn't generate sound on its own, but it can be guided by a background audio track to match the video generation. It's a truly impressive achievement. So how does it work?
The big problem with long video generation is error accumulation. Models are trained on clean video data, but when they generate, they have to base the next frame on the previous frame they just created, which might have tiny errors. These tiny errors build up, leading to the distorted, messy results we see in other models. Stable Video Infinity solves this with a brilliant idea called error recycling fine-tuning. It actively teaches the model to recognize and correct its own mistakes. During training, it deliberately injects errors from its own past generations back into the process, forcing the model to learn how to recover from them. It's like teaching the AI to spot its own hallucinations and fix them on the fly. For everyone eager to get their hands on this, the code has recently been released on GitHub under an open-source MIT license. They've trained separate, specialized models for different tasks. You'll find models for single-scene generation, multi-scene film style, cartoons, talking heads, and dancing animations. They note there is no inherent limit to the video duration. There's no mention of GPU requirements, but given the scale, you'll almost certainly need a large commercial-grade GPU for this. They've released almost everything, with a base model and a live streaming model still on the to-do list. The links for everything will be in the description for you to explore further. All right, the next model we have is called InterActHuman, and it tackles something really complex, multi-concept human animation with layout-aligned audio conditions. This is a powerful new framework for generating videos with multiple people or even people interacting with objects, all driven by separate audio clips. You provide photos of your subjects, their individual audio tracks, and it creates a single coherent scene with perfect lip sync for each character. First, let's check out an example with two people. The model is given reference headshots of a man and a woman, along with a multi-person audio clip. Now check the output.
The microfilm is in your ticket.
They're watching the north exit. Use the service tunnel.
As you heard, when the girl's voice speaks, her character is lip-synced, and when the man's voice speaks, his character is lip-synced. It correctly assigns the audio to the right person. Here's another 7-second generation with 3 different subjects. You can see that from just their headshots, the model has placed all 3 characters into a plausible, natural-looking scene.
So, what are we going to talk about now? What are we going to talk about now that we can talk?
I have no idea. What do you want to talk about?
And as the audio plays, it perfectly lip-syncs each person's voice to the correct character as their turn comes. The model also handles longer videos exceptionally well. Here are 2 characters in an 18-second generation, which is quite a long duration for this kind of task.
给我一个机会。怎么给你机会？我以前没得选择，现在我想做一个好人。好啊，跟法官说，看他让不让你做好人。
As you can see, the 2 characters have a full conversation in Chinese, and the lip sync remains accurate and consistent throughout the entire 18-second clip. This isn't limited to realistic humans either. Look at these 2 cartoon characters.
看来我不应该来。现在才知道太晚了。留下点回忆行不行？我不要回忆，要的话留下你的人。这样只是得到我的肉体，并不能得到我的灵魂。
In this 16-second video, you can see that while there's less body movement, the lip sync is perfect, and the model has generated both of them in a single scene from just their headshots. The compositions are also impressive. Here are headshots of 2 girls, and the model generates a 5-second video of them in a car.
I'm a hallucination. I want to say something important, something deep.
You can see the first voice is synced perfectly to the first girl, and the second voice is synced to the other. It's a really well-integrated and convincing scene. But it gets even better because InterActHuman also supports human-object interaction. You can provide an image of a person along with an image of an object. In this case, a jar of peaches and a boy's photo is provided. Now check the video.
Juicy peach fruit can, ready-to-eat snack or dessert helper. Fresh taste, easy to store. Try it now.
As you can see, the boy becomes a pitchman for the peaches with pretty good lip sync for the AI-generated audio. In another 6-second clip, a girl's image and a toothbrush is provided. The lip sync here is very, very good.
Soft bristle blue toothbrush. Gently cleans for fresh breath. Comfortable grip. Upgrade your oral care.
And in this example, a man is shown interacting with a fish. You can see him holding the fish in his hand.
Спокойная погода, хотя к моменту выхода этого видео погода легко может и поменяться. Однако еще...
And again, the generation is great and the lip sync is well done. It opens up a lot of possibilities for creating advertisement-style videos with characters and products. The model also shows strong domain diversity, meaning it can generate videos in all sorts of styles, including realistic humans, anime characters, and even talking animals. So how does it work? The core challenge is that for a scene with multiple people, the AI needs to know who is talking and where they are in the frame to apply the correct audio and lip sync. This is something most models can't do because they apply audio globally to the whole scene. InterActHuman solves this with a brilliant method. You provide separate audio clips for each person, along with their reference images and a text prompt. The model then uses a clever mask prediction system. As it generates the video, it's also iteratively figuring out the layout, predicting a mask for where each person is in the frame. It then uses these predicted masks to inject each person's specific audio only into their region. This ensures the right voice comes from the right mouth, even if the characters are moving around. When we look at the quantitative results from the paper, InterActHuman achieves state-of-the-art performance in lip synchronization and subject appearance fidelity, especially in multi-person scenarios where other models struggle. In a user study, it was preferred nearly 60% of the time for audio-driven tasks and almost 40% for multi-concept customization, beating out strong competitors like Qwen, OmniHuman, and Phantom. If you go to their GitHub page and click on Example Code, it will take you to the repository. The full polished code isn't available just yet, but they have recently released functional example code with complete instructions on how to install it. All the necessary links and setup instructions are there. There's no mention of specific GPU requirements, but this is a pretty advanced model. As always, I'll include the link in the description for you to check it all out. And in some other quick hit news, OpenAI has just rolled out its Storyboards feature to pro users on the web. This is a big deal because it lets you generate a full panel-by-panel storyboard to create longer, more structured videos. Alongside this, they've also bumped up the video generation limits for everyone. Now all users can generate 15-second clips, and pro users get a nice extension up to 25 seconds directly from the web.
Finally, the Deep Research feature from Qwen just got a massive upgrade that makes your insights both visual and audible. Before, when you ran a deep research query, it would just give you a detailed report. Now, that same report can be instantly converted into a live, interactive web page, making your data much easier to present and share. But even cooler than that, it can also generate a full-on podcast from your research. It creates a two-person conversational show discussing the topic you researched. And from the samples, the quality is seriously impressive.
2023 $206 billion. That's not a typo, right?
Nope, not a typo.
Yeah.
And get this, it was only $120.07 billion back in 2020. So we're talking about nearly doubling in 5 years. That's wild.
Yeah, like that's a 19.8% CAGR, which for software, insane.
Oh.
But also wait, different reports say different things. One says $206 B, another says $253 B globally, but US share is fuzzy.
Right. It's like everyone's measuring slightly different slices of the pie.
The speaking style is varied and doesn't sound robotic at all. The voices are natural and engaging. This whole suite is powered by their own stack. Qwen 3 Coder for the web page, Qwen Image for visuals, and Qwen 3 TTS for the podcast. It's a huge update and very similar to the podcast generation feature we've seen in Google's Notebook LM, but now it's paired with that awesome web page generator. So that was the AI news for this week. I hope you liked it. If you did, please let me know in the comments how you found this video. Be sure to leave a like, and I'll see you in my next one.